This lesson is dedicated to understanding component architecture, state and state management alongside one-way data flow. These three concepts are extremely essential to understanding how to separate your skills from the rest by building clean and structured components that implement design patterns and logical thinking. I'm going to walk you through each of these in more detail and finally show you a conceptual example, bringing everything together. It's important to grasp these concepts along the way, as components are one of the major building blocks on how we think about structuring an application. So to do this cleanly is essential for us to succeed, especially when it comes to managing complex data. So let's begin with component architecture. Component architecture is a way that describes how we think about our components. It encapsulates many ideas that form sensible opinions on how we can achieve application design. Designing components and their relationships with each other is as important as the UI and the data that they display. We also want to open up our components' flexibility, keeping them clean and composable for ultimate reuse. Components are in charge of talking to other components, passing state down the component tree, and binding events to pass changes back up when we want to commit a change. This is our first glimpse at the concept behind one-way data flow. Components can also be more self-contained and allow the user to change the state before committing to a change. This concept can be known as local component state, where we separate the data from the core state tree and allow the user to modify a copy of it before we then go ahead and commit those changes to our overall state tree. This technique also allows us to revert back the changes should we wish, but it also keeps the state changes predictable for when we make the updates. We're also going to explore parent-to-child communication and use some interesting concepts for passing data around our applications. These concepts will be applicable to any application you wish to build. I am here to strictly provide you my best knowledge on how you can achieve the ultimate component architecture skills. And this involves learning about smart and dumb component roles, which you may have also heard as container and presentational components. As we start introducing more complex state and component trees, this concept becomes more essential for us. Finally, we'll be strictly using one-way data flow and talk about the performance implications that it has on Angular. Not only for performance reasons, but our developer mindset and experience will really help us on our way to building a clean application. State and immutability is a big topic and something that needs to be clearly understood for you to succeed. State is essentially our application data, but it's represented over time. This simply means that the state can change, and over the years, sensible patterns have emerged to store, modify, and change the state in our applications in ways that are simple and make sense. The second topic to our state is in fact state management, which is how we reason about our state, share the state, and manage its updates. State is often kept separate from our components by means of a state tree, and this is typically injected into a component and then accessed via child components by passing the data down. State can also be kept inside of a store or multiple stores. A store is not only responsible for holding the state, but it provides means of accessing and updating the state. There are key considerations when updating our state as well, and this is done through immutable patterns, and this involves creating new objects every time that we wish to change the state in our application. Immutable updates allow us to avoid creating shared references in our application state and provide an easier to debug state tree. When using a sensible state management pattern, the state is then updated in a very specific place. This means that it's easily tracked and naturally becomes simpler to debug. Immutable patterns allow us to act more intelligently as well when re-rendering our component's update by checking the data structure's identity rather than attempting to detect any changes. This is because JavaScript data structures could be infinitely deep, and to check all the properties and all the values consumes a lot of processing power and, most importantly, time. To mitigate all of that, we can perform one very simple check on a data structure identity. This means that the identity of two objects are never the same. So if they are not equal, we know that something has changed, which then means that we can go ahead and render an update. Out of the box, Angular gives us this nice performance boost because it has all this built in for us. This now leads us on to the topic of one-way data flow. This simply describes the flow of our state in our application, which means it's easier to track application state changes. This provides us with more intelligent rendering through means of property inputs. Data only comes into a component via inputs, and when those inputs change, this comparison check that we were then talking about is made via identity, and an optimized re-render can then be made. One-way data flow also provides us with cleaner code intentions and patterns by allowing the data to flow just one way. It definitely aids our mental models and developer flow when constructing components and child components, passing data and hooking events back up to the top, resulting in less code to maintain for us. The phrase I like to remember is simply data down, changes up. We should avoid sharing references and mutating objects without first sending the change to the top of the component tree, and this is an essential thing for us to remember. The top of the component tree, in a typical example, would be a smart container component. We can then use this smart container, which we'll examine momentarily, to make our necessary state updates, and when those of them finish processing, we can allow the state to then trickle back down the components and re-render where necessary. So now we've looked at the core concepts, let's investigate them in action. With component architecture, we will expect a component tree that then simply goes and renders child components. But really, this example doesn't give us too much information because our components need data. What matters most is that we try to abstract the state away from our components, which helps us avoid keeping the state across multiple components. As our applications grow, this approach then gets very messy. It may seem simple and easy for a small application, but as it scales, and if we want to perhaps use the data elsewhere, it becomes far more challenging. By abstracting all the state from the beginning, this sets us up nicely for success to share the state anywhere with ease. Not only this, but updates are super clean as well, so it's a wise design decision and a practice despite the small extra overhead for us. So assuming that we have our state, this is then accessed via our top level component and then passed down to our child components through means of input bindings. So that's how we can think about the state. It exists at the top. It's then requested by a component and then passed down to further components. But this doesn't really give us the full picture. So we're going to change these definitions across to smart container and dumb components. And you can see here that the smart container is the component that's in charge of talking directly to the state and then offloading that state down to those dumb components. So let's put the brakes on, and I want to jump in and expand a little further on what we mean by these. Both of them are in fact components, but differ in a very subtle but important way. So here are some typical characteristics of a smart container component. Now, first things first, it's quite obvious. A container component contains child components and it wires the data and events up in them. State then travels in and out via our services, and this is a crucial aspect of the difference between a dumb and a smart container. The smart container essentially grabs that state from perhaps a service or a store. Smart containers are then in charge of passing the state to other components, our dumb components. They also then listen to those events from the dumb components for when the state needs to change. Smart containers are typically top-level components, which means that they are frequently used in routing. And we'll cover this as we start coding throughout this course. Finally, and this is important to remember, they're the least reusable components of all, because we're typically using them just once. But of course, we aren't limited to, and you can use a smart component multiple times if your application has that requirement. Primarily though, a smart container is in charge of grabbing the data and then composing and hooking it all in to our dumb components. So turning now to dumb or presentational components, they're simply in charge of rendering our HTML, templates, and state. We can also render further dumb components inside of a dumb component as well. These are just some sensible guidelines that have been established over the years. State is then given to a dumb component via an input binding, which is declared on a TypeScript class via a TypeScript decorator. We'll come on to this as we continue as well, so fear not if you've not used TypeScript. Any state changes we then wish to make can then be made locally inside of a DOM component. And once we are then ready, we'll then commit the change to the smart container, our parent component, which is then bound via an output property. This event that we emit contains the data that we want to then change. It's then passed off to a service via a smart container. The overall key here is that DOM components are simply unaware of services. We don't want to inject services throughout our DOM components. We want to keep them completely unaware, and that is also why they are given their name of DOM. They're not aware of the data and the state and all these smart things that are happening outside of them. I really like to think of DOM components as just small, pure functions. They're lean and they perform a single job just once. It's simply up to our smart containers to then control what is happening around our application and talk to the DOM components for us, which also means that DOM components aren't generally seen in routing, giving us the benefit of being highly reusable. We can use DOM components as many times as we need. So let's jump back into our conceptual diagram and add in that final service to tie in the full workflow of how a smart container then talks to a service, which then populates the state and then gets passed down the component tree. Our smart container would then typically be loaded by a route. We would then have some kind of service that's injected. The smart container then tells the service what request it wants to make. For example, load all the data. Once the service has finished loading the data, it doesn't just give it straight back to the container component. This is a crucial aspect and an extra step that is important to then add to separate that state from our components. So our service can compose the state and simply update the state. At this point, the smart container also wants to know about the state, so it then gets passed the new state after the service has been updated, at which point it can then pass it down to the child components. From here, we can then assume that a user wants to make a change, or maybe they perform an action such as a button click. This action or state change is then reflected by passing the data back up via an event all the way to the top from the component that initiated the change, back up the component tree to our smart container, and then offloaded to our service. At which point our service under the scenes might perform an HTTP action. It could create data, modify it, or delete it, you name it. Once that's finished, our state is then updated, and once again, our state then trickles back down our components, re-rendering where appropriate. Now, notice how the state only flows in one direction. You've now fully witnessed one-way data flow. The data flows down and events flow up. And you can see that with each change, we're not crossing any wires. It's a nice, predictable way of managing our state. So that concludes our architectural overview. We've covered smart and DOM components, their role in a component architecture, and the design thinking differences between the two. We've also covered a component's role in one-way data flow and understood how data moves around our application via not only services but inputs and outputs in our DOM components. We've also discussed immutable JavaScript data structures and their importance in modern applications. By abstracting the state from a component and managing it elsewhere, as well as incorporating sensible design patterns, we then get performance boosts out of the box by adopting these approaches. I sincerely hope that this lesson has then geared you up and you're now ready to dive headfirst into the world of Angular and component architecture. It's definitely an exciting journey and I'm very pleased to take you through it.